This is a crazy little artist's conception of a solar system being formed, a star being formed and the gas around it which would go into planets. This is an animation of that. And the idea, and I said earlier when we talked about accretion disks, you have stuff falling and it collapses down and into a disk, and then out of that disk planets are formed. And that is our best theory for how solar systems form. Now, there is, I mentioned earlier, role of magnetic fields. It had to do with a story about black holes and jets and stuff. Stars go through the same thing as they form. This was a remarkable result, which is the first spatially resolved measurement of a magnetic field in a star called HL Tau, where we could actually see the direction of the magnetic field. It did not go the way we thought. It was neither, pardon these words if they don't mean anything to you, perfectly toroidal nor perfectly poloidal. They had to do this kind of crazy model, which is on the right, to get it to line up, see how the yellow lines match the red lines. And it's a very highly inclined toroidal field, but nonetheless, A, this resolution, this observation was made, which had never been made before, and B, it didn't match theory. Yay, we love when that happens. Even more amazing then is the same darn star was huge headline hit the last couple of days because
yeah, back at Alma in Chile with these millimeter wave lengths, they actually imaged the disk forming planets. As you can take a look at it here. That's a real image. This isn't an artist's conception. And in these gaps, planets are forming. So this was predicted by theory. Theory said you should have gaps in a disk like this. This is the best image we've ever seen of this.
What's the spectrum for that?
What's the what?
Spectrum, what is that?
Well, you're looking
Those
at
are
millimeter
millimeter
wavelengths, so you're looking at things sort of like microwaves.
Okay.
So you're looking at glowing gas, generally molecules. That's the cloud it's in, that dark, dark cloud. If we go forward, that's a Hubble image of it. And we go forward one more, it's buried down in there. Go forward one more. This is our solar system compared to it. So this outer ring might be sort of where Neptune is, and this inner one more like Jupiter. So you were seeing a disk that's bigger than maybe we thought it should be. It's actually more settled down. This is a very, very young object. It's only about 100,000 years old. So
Now, not all of those gaps may contain planets. Some of them may be resonances where planets are sweeping things out, just like the gaps in Saturn's rings, where there isn't an object in there. It's just that you've got something that's in resonant orbit with something else, and it's kicking all the particles out, and you're opening up a gap.
But the fact that we have this one, and there will be more, let us study in detail planet formation around other stars. So we just love that the artist, they put an artist conception with the story, and who needs that, right? Because the data is so much better.